So today we're going to continue to solve systems, but we're going to do so by another method. And the method we're going to use today is addition and subtraction. And really the only time you do this is when the problem's set up in such a way that you're allowed to do it. Looking at this equation here, we notice that I have 3x plus 4y is equal to 7 and 3x minus 4y is equal to 8. Now, algebra tells us that whatever we do to one side, we can do to another. And I want you to take a look at these two problems in that 7 is equivalent to 3x plus 4. Now, that means if I know 7 equals 3x plus 4, instead of saying 3x plus 4, I could say 7 if I wanted to, but we typically don't. But notice, if I wanted to take and add the top equation to the bottom equation, that would be like adding 7 to both sides of the bottom equation. And if I did that, notice what would happen. Let's just say I add these up. I get 7 plus 8 is 15. Now again, keep in mind, I'm adding 7 to both sides. Even though this doesn't look like 7, we know it's equal to 7, so it is 7. When I add these terms together, I have 6x, and notice my y terms go away. So what I now have is I have one equation with one unknown, and that allows me to solve for x in this case. So what I've done here is I'm going to say I solved this problem by addition. I noticed I had two of the same terms that were opposites. I added them up, and I could do so because I'm like adding the same number to both sides of the bottom equation and getting one variable. Therefore, if I divide by 6 on both sides, I get x equals, 3 goes into each of these, 5 times on the top, 2 times on the bottom, and I get x equals 5 halves. If I want to find y, I have to plug this back into either of the two equations, and it doesn't matter which one. I'll do the top, so I get 3 times 5 halves plus 4y is equal to 7. It's 15 over 2 plus 4y equals 7. Clear the fraction by multiplying by 2, giving me 15 plus 8y is equal to 14. Subtract 15 to both sides. Get 8y equals negative 1, and y equals negative 1/8. So my ordered pair is 5 halves and negative 1/8. And because this is kind of odd, we've gotten a lot of integers lately, let's just take and check this. So I'll take 3 times 5 halves plus 4 times negative 1/8 and hope that is equal to 7. That's 15 over 2 plus negative 4 over 8, which is like negative 1 over 2, plus 15 over 2 is 14 over 2, which is equal to 7. So that checks. On the second equation, I've got 3 times 5 over 2 minus 4 times negative 1 over 8. That's supposed to equal 8. 15 over 2 minus times, or negative times a negative is a positive, and that's 4/8, so that's 1/2, which is 16 over 2, or 8. So that checks. So again, if I want to take and solve these systems by addition, I'm going to need two equations such that I have opposites within those two equations, and then I add the two equations together. You'll see in this case that's exactly what I have. I have two equations with opposites within those two equations. I know that 12 is equal to 5x plus 3, so 5x plus 3 really represents 12. If I want to add these two equations to each other, I would get a total of 27 and 9x, because the 3y's go away, divide by 9 to both sides, get x equals 3, substitute back 5 times 3, which is my x value, plus 3y is 12. It's 15 plus 3y is equal to 12. Subtract 15 to both sides, get 3y equals negative 3, and divide by 3. Y is equal to negative 1. Thus, the ordered pair xy is going to equal 3, negative 1. Now, in this problem, you'll notice I don't have opposites. They're exactly the same. So rather than add 8 to both sides, I'm going to take and subtract one equation from another. So in this case, I know 6 is equal to 3x plus 2y. If I were to subtract 6 to both sides, my problem would still be equivalent. So what I'll do is I'll take and subtract the bottom from the top. I have 1x minus 3x. 1 minus 3 is negative 2x. 2y minus 2y is 0. And 8 minus 6 is 2. So now I divide both sides by negative 2. And x is equal to negative 1. Again, I'll have to substitute. Negative 1 plus 2y is equal to 8. Add 1 to both sides. 2y is equal to 9, and divide by 2. Y is equal to 9 halves, so I have an ordered pair of 1 and 9 halves as my solution. You'll notice again, I have the same term in one equation as I do in the other. I'll take once again and subtract the bottom equation from the top. 12 minus 12 goes to 0. Negative 9 minus 7 is negative 16. Y. And when I subtract these guys, I get 32. Divide by negative 16 to both sides. Y is equal to negative 2. Make my substitution once again, and I'll say 12x minus 9 times negative 2 is equal to 114. Got 12x plus 18 is equal to 114. Subtract 18 to both sides. End up with 96 is equal to 12x. Divide by 12 in each case. Get x is equal to 8. So 8, negative 2 is my ordered pair solution. So another word problem. I have the sum of two numbers is 57. Well, I don't know my two numbers and they're not necessarily related, so I'll call them x and y. And their difference is 7, which means when I subtract the two, I get 7. And I need to find the two numbers. Notice I have opposites in this case. I can straight add these up. The 2x is equal to 64. So x is equal to, after I divide by 2, 32. Need to find my y. I have 32 plus y equals 57. Subtract 32 from both sides. end up with 25. So I have 32 and 25 as my ordered pair solution. You'll notice that they add to 57 and they subtract to 7, so I'm good to go. That's all we've got. Solve these two systems, write your lesson summary, and we'll discuss more tomorrow.